In this lesson, I will explain to you how constraint satisfaction algorithm works in EI with the help of example. Right here, I highly recommend if you didn't watch my previous video, please watch that video. I will give you the link in my description section as well because I have explained the concept of CSP constraint satisfaction problem there. Then it will be much more easy for you. So actually what we have to do here I'm going to explain you CSP with the help of example. This is my previous example. This is the map, right? Actually what we have to do, see these boxes, these different kinds of boxes are considered our variables. Colors are the domain, and we have to fill the color in such a way that neighbors cannot have the same colors, and these colors are available. So you can see this map, right? The neighbors, they do not have the same color. So here I have made the same example in order to explain this concept. Here I have four corners A, B, C, D. So these A, B, C, D are my variables because I have already explained to you that in CSP problems we can consider three things. One is the variable, this is X, right? So here we have variables A, B, C, D. Then we have to look after domain. Domain, here we have, suppose I will say I will pick three color, right? Orange, red, and yellow. These three colors we will use. This is our domain. And then the final important is constraint because it is called CSP, constraint satisfaction. We have to satisfy the constraint. In constraint, we have different restrictions or limitations. So in this diagram, in this simple diagram, my rules or restrictions are whatever color I will assign to A, and we have to pick these three colors, orange, red, and yellow. We cannot assign to B the same color. We cannot assign the color which we will assign to A to either C or D because these are the neighbors. We cannot assign the same color to the neighbor. Similarly, whatever color we will assign to B out of these three, we cannot assign to D because D is the neighbor of B. So how we can set our restrictions here is starting from A, whatever color, right? Initially you can assign orange, red, yellow, whatever you want. Whatever we will assign to A, we cannot assign to B, right? This is my first constraint, first rule. Second is same thing, we cannot assign that color to C either. We cannot assign to that color to D because see, we have this branch from A, this branch from A, and this branch of A. These three are the restrictions. Now come to the B point. Whatever color we will assign to B, we cannot assign to D, right? Because these are neighbors. Here you can see this is also the neighbor, but I have already said that A is not equal to B. So that is why I'm not going to write down that B is not equal to A because it's mentioned here, right? And the last is D, whatever color we will assign to D. So C is the neighbor of D, right here. So I hope this is clear. Why I am not saying D is not equal to B, because I already write down here that B is not equal to D. So these are my rules or restrictions or limitations. These are called the constraints. So we have to satisfy this constraint, right? And then we have to assign these three colors to these four corners. Before going to start, I will explain one more thing. So we have learned DFS, right? Depth for search algorithm. What happens in depth for search? And here, because here we are also going to use the same concept, right? But here we are using backtrack, which we also use in DFS. But this backtracking in CSP is called the intelligent backtracking. So now why we say intelligent backtracking for CSP problem and only backtracking in DFS? See what happens in DFS, depth for search. Suppose these are our nodes, right? So how we explore. When we reach here, and we will find that this is our not goal state. So we go backtrack. Then we will see if there are any further nodes here. No, then we go here, right? And similarly we go here. If this is not the goal state, then we go here. So it is time consuming because we have to go each and every node. But this CSP is the intelligent backtrack. Here we have to go back on that node where the problem arises. We cannot go each and every node. Suppose the problem is here, directly we will go here. So it will save our time. So we will use backtracking, but intelligent backtracking. Right, now we can start. Suppose this is my table. I can explain you here, but maybe you will not get easily. That is why I had made this table for you. So here are my A, B, C, D, 4 variables, and here are the 4 variables. Initial domain means initially I can give orange, red and yellow. Whatever color you like, you can assign to A. Same thing for B, same thing for C and D. These are our initial domains. Now suppose I say I want to assign orange to A. So just I am writing orange. O means orange. So here I will write down orange. What colors are left for B, C, D? See here, we cannot assign orange to B because this is the neighbor. We cannot assign orange to C, neighbor. We cannot assign orange to D. So what two colors are left? Red and yellow. It means we can assign red and yellow to B, red and yellow to C, red and yellow to orange. Because if I will say I am going to assign to B, right? So this is the rule. We cannot violate this rule. We have to follow these 5 conditions, right? Okay. Now come to B. Now same. A, I already assigned orange. Now for B, I say I want to assign red. So I will write down red here. Now follow your constraints. We cannot assign red to D, right? And we cannot assign orange to D because this one is coming from A and this is the neighbor. So what is left? Only yellow is left for D. And for E, we cannot assign orange because this is the neighbor, right? But red we can assign because you know B and C, there is no relationship. These are not neighbors. So what color we can assign? Red, yes, we can assign red to C. Yellow, yes, we can assign yellow because yellow is not assigned to anyone. So I hope this is clear. Right, now come to C. For A, we have assigned O. For B, we had assigned R, red. Now I say for C, I am going to give yellow. All 3 colors I have used now. This is left. D is left now. So can I assign yellow? This is yellow. Can I assign yellow to D? No. Why? Because C and D are neighbors. If I will say I am going to assign yellow here, which is violating. See here, where is this? C cannot be equal to D because these are neighbors. So what to do? I cannot assign anything to D because if I say red, this B is the neighbor. If I say O, A is the neighbor of D. If I say yellow, so it means this cell or this box will be empty or blank. But we have to write down here, otherwise we cannot solve the problem. So it means where problem arises, problem intelligent backtrack, problem arose here. So we have to go back here. So we will see what colors we can assign to C. Here I said red and yellow, right? In this. So instead of yellow, if I will assign red, so by default yellow is here. So we can assign yellow. So see, now you can see B, A is orange, this is red, this is yellow, this is also red. So neighbors are not same. This is the map coloring problem of CSP. Right, so I hope the concept of CSB is clear, that you have to focus on constraints. You cannot violate the rules which are set in the constraint. And this is the mapping problem. So now what is your job? Just change the color. Instead of orange, make it pink. instead of red, make it black, right? And this is blue. And just do it your own, because when you will involve, you will learn more. So please subscribe to my channel, share and like. See you in the next lesson, and thank you.